Fermi Learn to Share. This video is about stoichiometric relationships, including IB chemistry topics 1.1, 1.2, and 1.3. First, we will start with topic 1.1, Introduction to Nature of Matter and Chemical Change. Atomic theory states that all matter is composed of atoms and they cannot be created or destroyed. Thus, atoms are only rearranged in chemical reactions, meaning that the total number of atoms of each element must be equal on both sides. This is also the reason why we balance chemical equations. There are three main different kinds of substances. Elements are substances that cannot be broken down further by any chemical processes into simpler substances. Elements are the ones found in the periodic table, like carbon, nitrogen, and boron. Compounds are the atoms of different elements combined in fixed ratios. For example, water, H2O, has a ratio of 2:1 between hydrogen and oxygen. Mixtures are substances that are combined without chemical interactions. Mixtures divide into two types, homogeneous mixtures and heterogeneous mixtures. Pause and take a look at the states of matter and some characteristics of solid, liquid, and gas. These states, solid, liquid, and gas, can change states between each other with temperature. Changing from solid to liquid is called melting, liquid to gas is called evaporation, and gas to solid is called sublimation. These are all breaking bonds, which are absorbing energy. Changing from gas to liquid is condensation, liquid to solid is freezing, and gas to solid is disposition. These are all forming bonds, so they release energy. Specifics on energy would be covered in topic 5. The graph beside is another way to express changes in state of matter. With the 0 degrees Celsius as the melting point and 100 degrees Celsius as the boiling point, the periods at that temperature represent state change, while these sections represent temperature increase in specific states. Moving on to topic 1.2, the mole concept. The most important point in this subtopic is the Avogadro's constant. Avogadro's constant is when 1 mole is equal to 6.02 times 10 to the power of 23rd particles, where particles may mean the number of atoms, molecules, or ions. The example of the basic application of this Avogadro's concept is the following. How many carbons are in 0.5 moles of carbon? First, we are given 0.5 moles of carbon and we write it down and use the Avogadro's number to convert moles to the number of atoms. If we convert this, the unit of moles cancels out and we are left with 3.011 times 10 to the power of 23rd atom carbons. Molar mass indicated as an uppercase M represents the mass of 1 mole of any substance with the unit of gram per mole. It follows the equation of N equals small m over big M, in which N represents the number of moles and small m represents mass, big M represents the molecular mass. To give an example, to answer the question, how many atoms of carbon are in 12.00 grams of carbon, we need to use the molar mass. As molar mass can be found in the periodic table, we can multiply 12.00 grams of carbon to 1 mole over 12.01 gram carbon, which is the molar mass. And as the question is asking for the number of atoms, we do the same thing that we did above. We multiply 6.02 times 10 to the power of 23rd atoms per 1 mole. With all the unit cancellation, we will end up with 6.02 times 10 to the power of 23rd atoms carbon. There are different types of formula that we need to know to express in IB chemistry. Empirical formula shows the simplest whole ratio of atoms of each element. Molecular formula is the actual number of atoms of each element in a molecule. Lastly, the structural formula shows the arrangement of atoms and bonds within a molecule. Take a look at the following example. Glucose, or 36H12O6, would have an empirical formula of CH2O, as we use the simplest ratio of 6, 12, and 6. The molecular formula would be the same as the formula given, as it is the actual number of each atom. Structural formula would be expressed like this. Learning about drawing bonds will be learned more specifically on topic 4, so we just need to know that the structural formula shows arrangement of bonds for now. There are some properties that can identify as chemical reactions. First, new substances are formed. However, there is no overall change in mass when measured in a closed environment. Lastly, bond in reactants are broken and bond in products are formed, resulting in energy change between the system and surroundings. In a chemical reaction, there may be some cases when the reaction has limiting or excess reactants. Limiting reactants are reactants that gets used up, and excess reactants are reactants that have some leftovers. The limiting reactants determine the amount of products that would be produced. Let's take a look at an example. The question says that 0.1 mole of hydrochloric acid is mixed with 0.1 mole of calcium carbonate. Find the limiting reactant, excess reactant, and maximal yield of CO2 using the equation below. First, we need to start with 0.1 mole of hydrochloric acid. We find the molar ratio between hydrochloric acid and carbon dioxide. It would be 2:1 according to the equation. This would lead to the answer of 0.05 mole of carbon dioxide. When 0.1 mole of calcium carbonate is reacted to produce carbon dioxide, again using the molar ratio based on the chemical equation given, the answer would be 0.1 mole of carbon dioxide. The limiting reactant is always the one that produces less products. Therefore, the limiting reactant would be hydrochloric acid and exit reactant will be calcium carbonate. The maximum yield of products produced always depends on the limiting reactants, making the answer be 0.05 mole of carbon dioxide. Next, percentage yield is calculated from the experimental yield and theoretical yield. Experimental yield is from the experimental and theoretical yield is from the ideal yield. Calculated from the equation as we did when we were finding limiting reactants. The reasons for differences between these two may be due to loss, impurities, and incomplete reaction. Percentage yield is equal to the experimental yield over theoretical yield times 100. Topic 1.3 is about reacting masses and volumes. There are two gas laws. The first law is the Charles law, which is an experimental gas law describing how gases tend to expand when heated while pressure is constant. This can be shown through this equation. Gay-Lussac's law is ideal gas law where constant volume, the pressure of ideal gas is proportional to the absolute temperature, shown through this equation. To sum up all the gas laws, we can say that pressure is inversely proportional to volume at constant temperature, volume is directly proportional to temperature at constant pressure, and pressure is also directly proportional to temperature at constant volume. The ideal gas constant sums up the information given in the previous slide and makes it into an equation to apply to various things. We can use this equation to find some missing values in word problems. The standard temperature and pressure, also known as STP, is when temperature is 0 degrees or 273 kelvins and the pressure is 100 kPa. In chemistry, we prefer using Kelvin rather than degrees Celsius. Kelvin is equal to the temperature in degrees Celsius plus 273. Also, the volume of 1 mole of gas at STP is always 22.7 dm cubed per mole. It is important to know this as we are asked to use this number in paper 1. Percentage atom economy is the mass of desired product over the mass of products times 100. High atomic economy means fewer natural resources are used. For example, in order to calculate the atom economy for the production of iron by reduction of iron dioxide, we need to find both the total mass of products and total mass of ions formed. The total mass of product is 2 times 55.85, which is the mass of iron plus the mass of aluminum oxide, 2 times 26.98 plus 3 times 16. This would result in a total of 213.66 grams. The total amount of iron formed is 2 times 55.85, which is equal to 11.70 grams. Therefore, putting these values in an equation above, the atom economy is 52.3%. That's it for this video. Please leave a comment if you have any questions. Thank you.